Hello, Ferrand here. Welcome to the last part in the Cinema 4D C++ Getting Started Guide for Windows. So in the last parts we generated a build system and then built our build system and debugged it a little bit. And we were building a build system with MSVC. And in this part we are now finally going to write our own code. This video will be mostly about getting the structure of a module up and running and not about writing the most complicated plugin possible. In fact, we will be writing a Hello World kind of plugin, and we will also talk a little bit about the architecture of Cinema 4D and how things work in detail. So let's get started here. So to add our own plugin, what we of course could do is we could go here into example main and then the source code and then the object things and then into the rounded tube, which we already dealt with this example. And we could here add here our own, for example, object data implementation at the top and then at the bottom, for example, here in this function, call a registration function for our object data implementation, which we implemented, and this would then work. So this would then load in Cinema 4D. But the problem with this is, of course, that because each of these folders, which have here a project folder in them, will be compiled into a module binary. This would then mean that our plugin would always be shipped with the plugins which are also in the example.main module, which first of all would be a little bit weird for your users because they probably do not want half the SDK there. So if you implement a plugin, you always have to at least implement one module of your own. And a module which lends itself as a starting point is this example Hello World module. And what I'm not now going to do is open this in a file explorer, and we're just going to clone this and maybe give it a little bit more meaningful name, such as my project. Yeah, and now we have here this example, my project, and what we also can do is we can get rid of this README file because we don't really need this. And Hello World, the Hello World example, and by extension then also here my project code is an example for the minimal setup you need to get a module up and running. So to recap a little bit, what are modules? So when Cinema 4D boots, it will start loading modules one by one. These are for once modules which are shipped with Cinema 4D, so the so-called core libraries, which provides the implementations basically of what is exposed via the frameworks, the public API, but it will also load plugin modules. So example assets will be a module library, and Hello World will be a module library, and so on. And they all be loaded one by one. And this module can then contain either no plugins or one plugin or many plugins. That's entirely up to you. So let's have a look at the requirements for implementing such modules. So the one thing you need is a project definition TXT file. There's also a more complicated way to do this, but usually you do this with the project definition TXT file. Look into the build configurations and under the section native CMake configuration, there you can see how you can do this also in a different manner, but one way to do this is with project definition TXT files. or that's the recommended way to do it. And these files contain the build configuration of the module in which they are placed. So each module project has in this project folder, and there's this project.txt file in this, and this file defines the build configuration for this module. And in these files you can do the things you usually do in build configuration, so you can define header search paths and header file search paths, and you can define compiler options and linker options, and you can define build events and all these things you can do usually in configuration files. But this is not done in the code examples we ship here with the SDK, and instead what all these do is a bunch of configuration steps which are unique to Cinema4D, and we're now going to talk about what that is. So the first thing you have to do in a module configuration is to set the platform, and this basically determines in which build system this module will be included. So if we would, for example, remove here OS X as a platform, and if we would then generate a build system or regenerate our build system, then example my project would not be included if this build system would be for Mac OS. And if you would remove here Win64, then example my project would neither be included in a MSVC or Clang build system for Windows. Usually you leave this at the default of these three values, but you can technically modify this. And the thing you also always have to set in a module configuration is a type of this project, and this is usually always DLL for third parties. So DLL means that the thing will be on Windows compiled into in all cases it will be compiled into a dynamically linkable library, but under Windows this basically then means it's compiled into XDL64. lib is for when you want this module to be compiled, or this project to be compiled into a static library. So for example, if you go into the animation framework and look at its project definition .txt file, you will see it has the type lib. So lib is basically used for frameworks, and you usually do not implement frameworks as a third party, so you will never really need this. And app is to compile this into an executable, which is not possible for plugins. What you will have to configure sooner or later is the APIs, and the APIs are the frameworks which are accessible for this module. So, excuse me, if you would, for example, exclude here the asset framework from this list, this would then mean that this module here cannot include the asset_browser.h file. So in order to be able to include header files from a framework, you have to list them here, and the selection which is given here is sort of a good starting point for beginner projects. You will be able to do a lot with them. You can technically also just copy, for example, what the example.main project does, because this thing includes a lot of frameworks, but I would recommend in the beginning to keep it simple, and with these four you can do the vast majority of things beginners want to do. These two configuration settings you should just copy. They are fairly technical in their nature. You usually want to, or not just usually, you always want to enable this as a plugin developer, so C4D should always be true. And once you have set C4D true, you should re-enable style checks with this line. And style checks are basically something like uncrustify, or in Python the PEP8 styler. So this is sort of style validation engine. So it's not an auto formatting engine, but it's sort of enforces a certain code style. And when you do not conform to it, then you will either get warnings or outright build errors. You can technically disable this by setting this to 0. And the last thing which you always have to do is define a module ID. So this line here below. And as explained before, so when Cinema 4D boots, it will start loading modules, which it finds in the module paths. And before a module is being loaded, it must register successfully. And to do this, one criterion is the module ID. And this thing has to be unique. So Cinema 4D will not load two modules with the same ID. And we recommend using here this pattern, reverse domain notation pattern, net my company, my module. So where net.mycompany is derived from a web domain you own. So when your company, for example, owns a web domain, I don't know, foo.com, then you would write here com.foo and then .mymodule, or you can do after this domain pattern anything you want. This could then be as long as you want. What's noteworthy is that you should not use net.maxon, because if you do this, your module will not load, because Cinema 4D will know that this is not a Maxon module and therefore refuse to load it. There are also other criteria which can make a module fail to load, for example, when it's binary incompatible. So when a user tries to load a module which was compiled for another version of Cinema 4D, then this module registration will also fail. And another reason can be when a module is invalidly code signed and so on. But yeah, the important thing is you have to provide a unique module ID. And since we cloned this here from Hello World, we have to now change this. So let's change this to something like this. And that's already it. So we could do here a lot more, but the important thing is define the platform for which this basically should be compiled, define the frameworks which shall be used, and define the module ID of this library which is then compiled. And yeah, the other thing is the source code which we have to write, but I would say we now just regenerate our solution, because we of course added here now a new project. So we have to hit configure again and generate again. And we have still, or I had still Visual Studio open. And this now detected that we modified the solution. So we just say reload. And if we now collapse here the our main project, we see here our example, my project. And here's the source code of it, or the main CPP file. And so when we look at other projects, so for example, here's this example assets project, and we could also look here into example main image and so on. They all follow the same pattern. What you will see is that there's always at least a main CPP file, and then there are files which actually contain the implementation of plugins and whatever else this example module might be doing. And this main CPP file then contains by convention the handling of the module and the other files in the actual implementation. The Hello World example and my project does not follow this pattern to sort of simplify this, and we basically will now go over this structure. So the boilerplate code which is required to handle a module are these three functions: cinema plugin start, cinema plugin end, and cinema plugin message. And they are a little bit misleadingly named. You can sort of think of them as cinema module start, cinema module end, and cinema module message, because these three functions are operated by Cinema 4D to communicate with your module. And the cinema plugin start function is being called by Cinema 4D when your module successfully registered, and when then Cinema 4D starts loading your module, it calls this function and expects you to register plugins there. So a module has to register with Cinema 4D and can fail doing so. And then separate from this, 0 to many plugins could be registered by this module, and this is done in this function. And each of these plugin registrations can fail for various reasons. And it's then up to you to decide what to do. So this code example then says, okay, I returned false when this registration fails here, which would then mean that this whole module fails to load. So when we, for example, look here at, let's look at example.main, because there's a lot of code there. So here the same pattern. So we have here plugin start, and you see a lot of plugins being registered, and when one of them fails to register, then this whole function returns false. So therefore all these other plugins are not being registered. There's of course no absolute rule that it has to be like this. So you could of course also say, I don't really care if this registered gradient fails and I still continue to load other plugins. It's entirely up to you to decide this and if this makes sense. Yeah, that's what you do here in the cinema plugin start function. And then there's also cinema plugin end, and this function is being called when the module is being torn down by Cinema 4D, when Cinema 4D is shutting down. And what you can do here is free resources, write things to disk, and so on. Usually plugins do not implement anything there anymore because they are better ways to do this these days, but this is one of the ways how you can sort of do something when Cinema 4D is shutting down. And the last thing is Cinema plugin message, and you can sort of think as Cinema plugin message as a generic form of plugin start and plugin end, because Cinema plugin message will be called in various stages of Cinema 4D lifecycle. So it will be called when Cinema 4D is booting, it will be called when Cinema starts initializing its call libraries, it will be called when it's initializing the resources, when the plugins are started, and then in various stages while Cinema 4D is running. And it will also be called on the other end, so when plugins are about to be unloaded, when modules are unloaded, and then when the system is finally shut down. And plugin start and plugin end are sort of just aliases for certain phases or IDs in the cycle. And one thing you always have to do is implement this when the system is initialized. You have to check if the global resource is successfully initialized, and if it's not, you must return false here, because otherwise the resources in your module might not be working correctly. So to recap, you can just copy and paste these two basically into each of your modules, and you have to implement a plugin start where you register your plugins. That's all what you need to get a module up and running. If you look into, for example, here the main CPP of the example.main, you can see, so this thing, for example, freeze here some things, and you can also do here much more in this message function, but what we see here is basically the absolute minimum which is required. And what's also here a common pattern is this here, so a forward declaration. So we forward declare here this function register my plugin, which is then actually just implemented below here, so that we can call this function in this plugin start. And if you go back here to this main CPP file from the example.main module, we can, so here are the forward declarations. Okay, so here are two, but most of them are in the header file to this main CPP file. So here are a lot of forward declarations. And the reason why you have to do this when you do not put everything into one file, as I did here in this Hello World example, is because the registration functions are then implemented in the dedicated files which implement the plugins. So here, for example, the rounded tube example at which we looked now multiple times. Here at the bottom, here's the implementation for the actual registered rounded tube function, because these registration functions then call the internal registration function for a specific plugin type, and these functions always need access to the implementation which they register. So here, in the case of the rounded tube example, it needs access to the allocator to this thing, so Cinema4D can actually instantiate a rounded tube object, and therefore you have to put them into the implementation, and therefore you need this forward declaration dance. So let's close all this stuff here and also close this and go back to our main CP. So this is here the usual content of the main CPP file. So forward declaration, plugin registration, module teardown, and module messages. And an actual implementation of a plugin then usually looks like this. This can of course be spread over multiple files, but the general pattern is that you have here a plugin implementation. In this case, we implement here command data plugin. So a plugin which appears as a button or menu entry in Cinema4D, and the user then can click on it, and this will effectively just execute the function, namely the execute function of this command data plugin, and we here just print hello world to a dialog box, but this thing could basically do anything. So you could also search the document and then do something with the found object also. So these are the typical command plugins. This thing does not have a GUI by default, but you could also implement here GUI. This gets in all much more complicated, but this is a good starting point to get started with our API. And the plugin registration then follows here this pattern, which is seen here. So you always need a unique plugin ID. So the Cinema4D again loads modules one by one on when it's booting, and modules can fail to register, for example, when their module IDs are colliding. And then when a module has been successfully loaded, it's being asked to register its plugins, and plugins must also being registered one by one, and they also have an ID each, and they can also collide, and therefore this ID needs to be unique, because if the thing is not unique and there's another plugin on your system which uses this ID, then this call here will fail. So because we cloned this here from Hello World, this thing is not unique. So if you would go here into Hello World, you can see that the IDs here, of course, the same. I hope I have the right one open now. Yeah, I have. So I'm going to replace this with this ID here. And you can get, or you must get, your plugin IDs from this URL. So other than the module IDs, which you more or less can invent yourself, you definitely cannot invent these yourself. You must go to this link and then register there, and then you have basically access to a plugin ID generator on which you can just click and it spits out new plugin IDs for you. And I have done this here for this ID. And the plugin registration then usually follows this form that you implement here a custom function, and this could register one or many plugins. It's totally up to you. And you then call internal registration function or a built-in registration function for the plugin type you implemented. So we implement here a command data plugin, so we call it this register command plugin, and they then generally follow this form. You pass a plugin ID, you pass the name of this plugin or the label of this plugin, some plugin flags. Optionally, you could also pass here a bitmap, so the icon of this plugin, and a tooltip. And in the case of command data plugin, you pass an instance of the of this command plugin, or in the case of a node like the rounded tube, which we saw a few minutes ago, you pass the a pointer to the allocator function so that Semaphore-D can instantiate your plugin. There are some slight differences between different registration functions. So, for example, nodes also want you to pass the description, so the resource for the plugin, but in general they all follow this general pattern: plugin ID, at least a name, plugin flags, often an icon, and then either the instance of the thing or pointer to the allocator function. And this thing can return true or false. And yeah, so when this thing returned false, it means the registration failed, and then of course your registration function should return false. And here you are then basically what we talked about earlier. It's your decision then either to say, okay, when this thing failed to load, then I will not even try my other plugins, or you could also say I don't really care and print an error to the console. Yeah, this is pretty much it. What's to say here? Let me just change this to something that we can differentiate this a little bit more easily in Cinema. So this is my project, and let's also change this. Yeah, and that's pretty much it, what we have to change here. So let's click now Build. And look at the build output. Everything is correct here. Just as just to repeat this, for example, we see here this interface registration, registered CPP. This is the output of the soft processor, as we talked here about before. And then, of course, it compiles here our main CPP. And this is then here put into the example, my project XDL64. So this is the actual plugin binary, which we generated. And now we can just press play. If I didn't screw it up, yeah, so we have here now our hello world my project command. You could of course also just press Shift-C and then type, oops, hello world. We will also see it here, and if we click it, then this dialog box is being opened. Yeah, this concludes the series for getting started with the Cinema 4D C++ SDK under Windows. I hope this helped and you learned a few things. There are of course much more things to explore, but this is now up to you to go into the details of things. Happy coding and happy rendering. Bye bye.